Hello world, this is Lisa Friedrichsen, your friend and computer science professor with another installment on Coding Bootcamp 101, what you need to know before spending 10 grand or more on a coding bootcamp. If you've been watching this series, you know the goals are to provide a logical, affordable, and effective way to attack the 5 areas of the full stack. And I define the full stack in these two major categories, the front-end technologies of HTML, CSS, and JavaScript, and the back-end technologies of a server-side language such as PHP and a database. But there are many different options on the back end, and we'll talk about that in this screencast. But putting all these technologies together makes you a full stack developer. I would recommend learning the front-end technologies of HTML, CSS, and JavaScript first before you move into the back end. If you're going to do a web app, you're going to be delivering HTML, CSS, and JavaScript to your client, to your user, to that mobile phone, to that computer, to that iPad. So you're going to need to learn these first three front-end technologies anyway. And I think it makes it easier to learn the back-end technologies once these front-end technologies are solidly under your belt. Let's drill down into the database options. As you know, a database is a collection of information that is organized so that it can be easily accessed, managed, and updated. And there are different models by which to organize your data. But I highly recommend you first learn about the relational database model because it is by far and wide the most popular, powerful database model out there. A relational database consists of tables of records linked together in one-to-many relationships. And there are many different relational database software programs that do this, such as IBM's DB2, Oracle, MySQL, which is an open source relational database model that's commonly used with PHP and Python. There's also Microsoft's option called SQL Server, and it works well with Microsoft's Visual Basic program, Microsoft's C# program, and the ASP.NET framework. Another option is PostgreSQL, which is commonly used with Ruby and Rails. And then there's even Microsoft's Access, which is real handy for small local apps. Now, number 3 is SQL, Structured Query Language. And I need to make the point that SQL is a standalone language used to select, append, update, or delete data stored in relational databases. In other words, you use SQL or a slight dialect of SQL in all 6 of the relational database management programs seen in number 2. So no matter what relational database program you're going to be using SQL. SQL at its core runs against all relational database programs. And this whole model in SQL was developed way back in the 1970s, I believe. So it is such a solid and significant technology that you really do not want to rush through your database knowledge. You want to learn this solidly because the data, the information that your web app manages is probably the heart and soul of that web app. In this window, I've opened MySQL. MySQL is one of the most popular web app relational databases. It runs back on the server because, after all, you have to have a central location to store all your data. When you download and install MySQL, and there are several good YouTubes on how to do that, you will get this free sample database called the Sakila database. You will be able to open up this ER diagram window, which shows you the model of your database. Each of these little squares represents a table of data. And this ER diagram, entity relationship diagram, is color-coded. So the orange tables are customer data, and if I move the window to the blue tables, that's our inventory tables. If I go to the green tables, that's our payment tables. And our yellows are our views or our queries of how we want to look at data from different tables. For example, sales by store. But let's move back to our customer data. Each one of these little squares represents the fields or the columns that are in that table. So the country table has country ID, country, and last update field. And right beside the field name, we see the type of data that field is identified to store. So for the country ID, it stores a small int, a small integer. For country, the varchar data type is given with a 50, variable characters. So that's a textual type field with 50 character spaces. Last underscore update field is given a timestamp data type, so it can only store a time. So after you read your fields and your data types for each of these tables, you start noticing these link lines. And that's really what makes a relational database powerful, because it allows one table to be related to another table. It allows one record in a table to be related to many records in another table. And this in turn minimizes redundant data. Let's take a tiny example to see how this works. So one country, such as the United States of America, can be related to many cities. So when we record a new city in our database, instead of writing out USA, 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 or worse yet, United States of America, United States of America, United States of America, for each city in the United States of America, we list the country once and simply link it many times to the many cities that are in the United States of America. Similarly, we do that with cities. One city can be in many addresses, and one address can be connected to many customers because perhaps we have many customers in the same business or the same business address. So we would not want to write that complete address out every time. We'd simply want to point to the address for the many customers that we're shipping to. I think this is easy to see in Access, and even though Access is not a great tool for web development, it's a great learning tool for relational databases. Here I've opened up the Northwind database. Access provides the Northwind database as a sample database full of data because it's all local and because the installation is so easy and because you already probably have Access on your computer, it's a nice place to learn about relational database benefits. Let's just take one relationship here from customers to orders. Now in Access, we call this the relationships window as opposed to the entity relationship diagram, but they're essentially the same thing. Also in Access, our table field lists just tell us our field names and identify the primary key field in each table. The primary key field being the field that contains unique information per record. It doesn't tell us also the data type of each field, so it's a little bit simplified. We can clearly see that one customer can have many orders. So the customer ID field is put in both tables so that as my customer makes another order, I do not have to repeat their company name, their contact title, their address. I simply record their customer number in that orders table, and I can reach out and link to and select any data using SQL in the customers table because I've properly linked them. So let's see this in action. I've created a small little query here called customer orders that actually has the company name from the company table, the order date from the orders table, quantity from the order details table, and the product name from the products table. And for example, this is a pretty long company name. And so if this company decided to shorten their name to Anna T, watch what happens when I move to another record. That's something you can demonstrate very quickly and show the power of a relational database. And the reason that happened is because that customer name is only recorded physically once in the customers table. Whereas in this view, in this query of the data, it was selected 10 times because that customer placed 10 different orders. Power of a relational database. Data is recorded only once so that no matter how many times it's selected, if it's updated, all views, all queries of that data are automatically updated as well. The other thing you can do with Access, which is really quite nice, is go into SQL view, and you can actually read the structured query language, and when we're selecting records, it starts with select. You can actually read the SQL that was created by Access to select data out of this relational database, even though this is a small little product. But if you wanted to use Access as a way to teach yourself SQL, you could go to SQL view and just write out the code that you needed and practice your SQL statements. And there's a company name in the city from the customers table, just as if I had created that query using Query Design View. So that's relational databases. It's tables of records linked together in one-to-many relationships. The full stack, HTML, CSS, and JavaScript on the front end, and then databases and server-side languages on the back end. The server-side language will help grab data out of that relational database that you've set up and then serve it to the front end in a web page. My high recommendation is that you should learn the relational database model first, and you should spend a great amount of time learning SQL because you'll be sticking SQL into your server-side language statements to select data out of the database to show the user, or to insert data that the user has provided in a web page, or to update data that the user has provided in a web page. So the server-side language is going to work with that relational database model. And the way it's going to work with the relational database model is through SQL. It's a critical and scarce skill to understand the one-to-many relationships between the tables of a relational database, but it's extremely satisfying. Thank you.